In this lecture, we will learn how to use emissive materials. As you progress through your project development, you may find the need for materials that emit light on their own, often referred to as glowing materials. In Unreal Engine, these materials are called emissive materials. Emissive materials offer artists a cost-effective and powerful tool to achieve the effect of surfaces glowing or emitting light without relying on Unreal's standard light types. With the right configurations, emissive materials can serve as genuine light sources, casting illumination into the surrounding environment. Alternatively, they can self-illuminate without emitting light into the scene, offering flexibility in achieving desired visual effects. In the resources of this lecture, I added a light bulb mesh. Please download it and add it to your project. I created a folder called Lightbulb in the Meshes folder of my content browser. I will drag and drop static mesh lightbulb to this folder. Now I will click Import All. Don't worry if this window pops up. It won't interfere with our goals, and later I will teach you how to get rid of this warning. At the moment, you don't need to arrange the materials in appropriate folders as we will change them soon. Now double-click on the lightbulb mesh to open it in a separate tab. In the Details panel, we can find a tab called Material Slots. This lightbulb mesh uses 3 different materials. Usually this part of a real light bulb is made out of metal. Lucky for us, Unreal Engine has us covered as metal material is included in the starter content. Let's apply it now. To change the material, you need to expand this tab and search for metal. Choose the one you like. It looks a lot nicer this way. Okay, now we need to create a material that emits light. Go to your materials folder in the content browser. Create a new folder and call it Emissive Materials. Open it. To create a new material, right-click somewhere within these margins. Click on Material. Give a name to your material. A proper naming convention would be to start with capital letter M, then underscore, and then the name of the material. Open the material by double-clicking on it. Right-click somewhere in empty space and search for constant 3 vector. Click on it. Now you need to connect these 2 nodes. Drag the connection wire from this tiny white circle to the base color of the material node. Double-click the Vector 3 node to choose its color. Make it white. Okay, let's analyze what goes on here. We are using this constant 3 vector to create a color. It represents an RGB color model short for red, green, and blue, form the foundation of digital color representation in computer graphics and displays. In this model, each color channel red, green, and blue is assigned an intensity value ranging from 0 to 255, where 0 represents the absence of the color, and 255 represents its maximum intensity. By combining different intensities of these 3 primary colors, a wide spectrum of colors can be created. For instance, mixing equal amounts of red and green produces yellow, while combining red and blue creates magenta, and mixing blue and green yields cyan. The RGB color model is extensively used in various digital applications, from image editing software to web design, providing a versatile and intuitive way to represent and manipulate colors digitally. This white line over here is a connector between the nodes. Some like to call it wires while others call it noodles. In our case, it's connected to the base color of our material. Basically, this means that the material should use white color as its base color. Materials have tons of other options, but we will leave it for relevant lectures. At the moment, we are interested in this emissive color input. It dictates whether this material should or shouldn't emit light. To make it emit light, we can attach a constant to it. Right-click somewhere in the empty space and search for constant. Connect the constant output to the input of emissive of the material. Nice. Now you can play with these values to make material glow with different intensities. In this small preview window, you can see how the material changes based on the value we input. Obviously, the higher value yields more intensive light. I think value of 2 looks good. Don't forget to save changes by clicking on this button or by using keyboard shortcut Ctrl and S. Now we can return to our light bulb static mesh. Expand this material slot and look for the material you just created and select it. Now would you look at that? Now it doesn't only create an impression of glowing, but this light bulb will actually illuminate its surroundings once we import it to the level. But before doing it, let's save the changes we made in this static mesh by clicking this button or using keyboard shortcut Ctrl and S. To quickly return to location of this light bulb static mesh in your content browser, you can click on this small icon. Now drag and drop it to your level viewport. If you look closer, you can actually observe how our light bulb with the emissive material we just created actually illuminates its surroundings. Now you know how to create and apply your own emissive materials. We'll be using emissive materials as we progress through this course, and I will teach you even more tricks to change properties of such materials in the runtime. For now, I think we should stop here. Please don't continue to the next lecture until you are able to create and apply your own emissive materials without my assistance. If you have any questions, I'm always available in the QA section of this lecture. Thanks for watching. I will see you in the next lecture.